Hello, my name is Elliot. Our project WebLight is an innovative way of using Arduino Uno to control a number of different functions over the internet via a web portal with just a click of a button.
Hi there, my name is Callum and I'm going to give you a quick demonstration of the project before showing you the hardware and then the website code. I do firstly apologise for how scruffy the Arduino looks. It's difficult to keep it tidy using the jumper wires. Here I have my computer connected to the same network as the Arduino. I'm loading a web page from the Arduino itself, which is hosted on the SD card on the Ethernet shield. All I've done here is navigate to the IP address of the Arduino, which you'll see more of in the code. The website here contains buttons which represent all of the functions we've programmed in. For example, this row of buttons controls the different colours of the RGB LED, as you can see. Pay attention to the colour of the button on the website. It changes colour to represent whether the program is turned on or off. You'll see how I did that when I show you the website code. We've also added the ability to change the brightness of the LED with these 4 arrows here. The arrows represent the brightness levels 20%, 40%, 70% and 100%, with the default being 100%. Another function includes the use of a piezo speaker to play songs. We only have one at the moment due to technical issues, and that is Twinkle Twinkle Little Star. The final thing we've included on the website is the room's current temperature, which is being read by the temperature sensor here. This updates whenever you reload the page. So the hardware involved includes a device with a web browser connected to the same network as the Arduino. I'm using a switch to host a local network, but you could use a wireless router in order to access the Arduino remotely and use a mobile phone. I've got an Ethernet cable going from the Arduino to the switch and another going from the switch to the computer. Then you have to set a static IP address for your computer on the network. Here I've got the Arduino with an Ethernet shield on top. This holds the SD card. Connected on the breadboard is the RGB LED, a temperature sensor and a piezo speaker. Now here is the code for the website. I'll keep this brief in the interest of time, but the code is all available on our GitHub page. The languages used here are HTML, CSS and jQuery. We start by declaring the doc type as HTML for compatibility, before setting a title and then referencing the jQuery library. Then I start writing the styling for the page. I've done it all in line as Arduino struggles with referencing other files and it wouldn't recognize the external CSS file. These first three set the parameters for the page, including the width of the container, the background color, border and the shadow effect. These next parts provide the styling for the buttons, including the gradient background and the sizing properties. These two are for the key reference in the top right of the page, and these are for the brightness buttons. This final piece sets the size and positioning for the temperature reading, which is important due to the Arduino controlling that aspect of the content. Here I have placed the jQuery used. This first function works by replacing the class of an element whenever it is clicked. In this instance, the buttons which are red class are given the green class when clicked, and those with the green class are given the red class. This is how the effect of changing the background color of the button is achieved. This next function is used to discretely change the URL extension to activate a case statement. This is done by using an AJAX GET request, which sends the request in the background, and this works by adding a $ and the case ID to the end of the URL. From here onwards is all of the content for the website: headings, buttons and text. To further explain how the jQuery works, each button links to a program number or letter, which is then added onto the $ with the AJAX request. This activates the corresponding case within the Arduino. Each button also links to an ID, which is the button that changes color when clicked. For this one here, the ID is 1. This div here has the ID of 1, so this button red class will be replaced with the button green class.
Okay, so for a brief run through of the code, we've got our library inclusions here, including pictures.h, which is a local library attached to the twinkle function. We've got some various definition readings here. We've got the Ethernet configuration settings, which is for the Ethernet shield. That's for communications, obviously, with the clients across the network. Setting the Ethernet port arrays for the pin counts. Some Boolean values here to control the brightness. Later on, you'll see how those are used. Now, within the setup, we obviously have serial.begin, declaring our pins now as output pins via the array. we've used the manual setup for the Ethernet as you saw above. There is commented out here is the standard way of doing it. We had to do it manually to make it work for us. We begin listening for incoming connections. We then print out the IP address of the Ethernet shield. We initialize the SD card using pin 4. Pin 4 is the chip select pin. That means it will be constantly on. So we can't use pin 4 for any other functions or attach it to any other functions whatsoever. We print various text strings here depending on whether the SD card is found or not found. As long as it is found, we'll carry on and declaring file a web file. The loop itself is very simple. It's only one line because we have one main function that calls within it other functions. The function itself is called check for client. Okay, so running quickly then through the check for client function, we check to make sure we have a client and that the client is available. We check the client is also connected to the server. Once we're sure that the client is there and is connected, we get the data available to the client's data available to read. We then move through the function, send across the header. We start reading C, which is 1 byte, as you can see there, CHAR. Effectively, what this does is it's a GET request from the website HTML. So it'll run through effectively the entire URL, and it'll look each single value one by one until eventually it hits either a space, which is denoted here, or the $, which is denoted here. If it finds the space, it'll stop reading. It'll see here that reading is false, and it'll just stop what it's doing. If it, however, finds the $, it'll start reading properly, and it'll go then further through the function. The $, itself would be in the format of, you have the URL which ends in 177, then $1 would then be case 1, /$2 would then be case 2. So we are effectively setting our pins here, quite simple. Go into our switch case statement, which now the value here of C is being taken as either 2, 3, whatever the case is, so it's whatever comes after the $, we mentioned earlier. These first cases themselves are simple switch on and off of the LEDs. Moving further down, we call the twinkle function, which is the pitches.h that we saw earlier is connected to that. Slightly further down, we can see here pin 9, which is our red pin from the RGB LED, which we set up manually rather than using RGB code. We set it up manually, so 4 separate resistors, 4 separate pins, red, blue, and green, and the common anode pin. C1, which is one of the Boolean values above, later on helps to control the brightness. Once we get down to here, we use pulse width modulation, which effectively flashes the pin at 20% brightness. To us, 20% brightness is actually pulse width modulation, which is flashing the pin at a certain level. The human eye would consider that to be duller than what would be 40% or 50%, 60%, which would be much faster flashing. That's how the human eye is interpreting that. This carries on to 40% and so on until we hit 100. Moving on down to here, we check if the URL contains a new line or if it contains 2 characters. Effectively, if it contains 2 characters, say it was $, and then 1, 2, the ASCII value of 1 and the ASCII value of 2 would be taken rather than the ASCII value of 12. It splits those up into 2, so you could call 2 functions at the same time. However, we've not really needed to use that so far. Moving on down here, we open the web file, we then send the web file across to the client, then close it. Our temperature sensor function using analog read A1, we have a span in the website called sensor1 that sends the value, which is set here and turned into degrees Celsius here by this maths calculation. And we close the client here with client.stop. The last function, void twinkle, here is very simple. It's one of the music functions that you'll have seen through various of the tutorials that we go through last semester. Other than that, that's really the basis of all the code. Unfortunately, we couldn't go through in much more detail, but hopefully we will be able to if there's any more questions later. For a very brief look at the schematics for this, simply your temperature sensor connected over to A1 here. Your wires for the LED, this is the RGB that we set up manually as I mentioned earlier. Red pin going over to 9, blue pin going over to 6, and green pin going over to 3. Also your pin 5, which is the pin set for the twinkle function, which plays through the piezo speaker. Okay, so the possibilities and the functionality of Project WebLight. In-home security, anything from pressure sensors to movement sensors, or you can be notified using a wireless network or a wired network. In-home device control, TV, stereo, heating, again, can all be controlled via the Arduino if coded correctly. Wireless networking capabilities are endlessly. If you have the wireless shield rather than the Ethernet shield, there's a lot more you can do with this, being that you don't have to be solidly connected to a network all the time. Long distance control of sensory functions, any kind of water meters, any kind of meters that need to let a department know, say a maintenance department, when something needs topping up or something needs renewing, filters, anything of that nature. This could be used for that kind of thing. Functionality issues is somewhat like the problems that were mentioned before. Arduino Uno's processing power is pretty limited when it comes to this kind of thing, and a lot of the I mentioned a minute ago, a lot of those things will not work with an Uno just because of its processing power alone. There isn't enough pins. Something like the Duo and other Arduinos or other microcontrollers have more pins and more processing power, and as such would be a better choice. Ethernet shield is limited to certain tasks. Obviously, it's pretty self-explanatory that it has to be connected all the time to the network. You can't really take it that far. With a long cable isn't going to stretch that far. Network security, compatibility issues. We couldn't, for example, use the university's network. We had to create our own with the switch because we couldn't run this through the university's network without encountering various barriers, etc. Number of users that connected to the website at one time is limited. We haven't really managed to test just how many and how that would react if 2 people, 3 people tried to do the same thing all at once. We weren't able to get enough hardware to test that, but I'm pretty sure that would break it. And the hardware itself, as I just said, is very temperamental. If you do make any kind of overkill on the project, it will cause a big problem and everything will shut down, and then somebody would have to go to the Arduino itself and reset it, reset the code, etc. So overall, the Uno is not the best bet for this kind of project. We couldn't find anything like this online. Nobody seems to have managed to actually do all of this together. They've done various bits, but nobody's managed to put a package together that actually works like this. So we were happy with what we'd done. Unfortunately, with better hardware, we would have been able to accomplish more.
In the beginning of the project, we struggled to make quick progress in the shape of the idea. We spent many weeks discussing and thinking, and in the end we spoke to our lecturer, and through mixing ideas, we finally came up with our project. Another issue we had was setting up the local network for the switch so we could control the Arduino via our own laptops. We resolved this problem eventually by realizing that we needed to set up a static IP for the computer and add the MAC address for the Ethernet shield into the Arduino sketch. The final problem we encountered was to do with the songs that we were planning to play on the Arduino. We had planned to have 2 songs, the James Bond theme and Twinkle Twinkle Little Star, but due to a conflict issue while calling multiple functions within the case statement that caused the website not to display, we decided it was best to stick with one as we knew it would work.